All right, section 5.9, titration. Now, this is a technique that you'll be doing in your Chem 1141 lab. Some of y'all are not taking Chem 1141, so we'll just go ahead and proceed. But what this technique is used for is to determine the concentration or number of moles presence of a substance by a technique. And so basically, it's a way of using a known solution to determine the concentration of an unknown solution. So titration is a laboratory technique for determining the number of moles of a substance dissolved in an aqueous solution. Okay? One reactant, also known as your standard solution, has a precisely known concentration, so you know the makeup of that solution. The volume of the standard solution and the sample are both very carefully measured. The mole ratios and volumes are used to calculate the sample concentration. Okay? Now, the steps in a titration are as follows. One reactant, also known as the titrant, is slowly added to the other. Now, there's a particular piece of glassware used known as a burette, and a burette is a piece of glassware that it looks like a very tall cylinder, it is a very tall cylinder. Then it has a valve right here, and then it has a spout. Okay, now this valve right here, the way that it's positioned right now, keeps the solution in here. So this would be known as its closed position. You change the positioning of the valve, you take it from this horizontal position to a vertical position or an angled position, and then all of a sudden the solution that's in this burette, which I've shaded in red here, begins to flow out. Okay, and what's the most important part of this piece of glassware is you have demarcations along the tube itself. So at the very top, or not the very top, but the highest demarcation is going to say 0 milliliters. The lowest demarcation, which is not at the exact bottom of the burette, it's going to read 50 milliliters. And what you're going to see is as you open this valve, the solution is going to go down. And at some point you would say, okay, well, I'm going to let it flow and then I'm going to stop it. And if it reads 2.5 milliliters, that means you've let 2.5 milliliters of your solution flow through that burette. Okay, so below that burette, you're going to have a piece of glassware. Generally, you'll use an Erlenmeyer flask that has your unknown solution. Now, what you would do to this unknown solution is you're going to add an indicator solution. So an indicator is added to the reaction to indicate the end point of that titration. And so generally, what we will use is we'll use something like phenolphthalein or some pigmented indicator that is sensitive to pH. So at the end point, the reaction is at or very close to the equivalence point, where all of the substance being titrated has reacted with the titrant. Okay, so what that means is if you have 5 moles, I say 50 moles of X, then you would see a color change when you've added 50 moles of Y. So you're trying to get these things to balance out. The volume of the titrant added is determined by comparing the initial and final burette volumes. And I'm going to have a video that I'll post on our Canvas page that you can watch as kind of a supplement to what the actual technique lays out as. But here, what I'd like to do is go ahead and work through a calculation. Okay, so calculate the concentration of an HCl solution. HCl is a strong acid. If 25.00 milliliters of HCl is titrated with 0.2000 molar sodium hydroxide. Okay, the initial burette reading is 2.17 milliliters, and the final burette reading is 39.42 milliliters. Okay, so what this basically boils down to is in the burette, we have, here's our valve, here's our spout, here's our Erlenmeyer flask where we have our 25 milliliters of HCl. We've added to this from our burette, well, we've added sodium hydroxide. We've added, let's see, what's the volume? What we need to do is we need to take our final burette volume reading and our initial and say 39.42 minus 2.17. That will give us our total volume titrated. So 39.42 minus 2.17 gives me a volume of 37.25. So we've added 37.25 milliliters of sodium hydroxide with a concentration of 2.000 molar. Now essentially what this shows us is we know the concentration of sodium hydroxide, we know the volume of sodium hydroxide that we added, we know the volume of HCl that we used. What we don't know is the concentration of that HCl solution, which is what we're asked for. And what you can do, and what I like to do, is set up an equation. HCl plus NaOH yields H2O and NaCl. Now, looking at this, you have 1 mole of HCl reacts with 1 mole of sodium hydroxide to produce 1 mole of H2O. Now, what we're going to do is we're going to take our concentration of our NaOH solution, 2.000, and we're going to multiply that by our volume of our sodium hydroxide solution, which is 37.25 milliliters. And we're going to set that equal to, let me erase this real quick. We're going to set that equal to the concentration of our HCl solution, which we're going to put in as X. I'm going to put parentheses around that. We're going to multiply that by the volume of HCl, which is 25 milliliters. So essentially what we did here was a C1 V1 equals C2 V2. Oopsies. V2. This is similar but different from a dilution calculation, but we use the exact same setup. Now, a question is, what are the units of our concentration going to be? Well, I'm going to go ahead and work through a little bit of this problem. 25 milliliters. And then we're going to be left with, well, molar. So our concentration is going to be in molarity. I'm going to set this up, and the reason we can do this is because our volumes were both in milliliters. So I'm going to say 2.000 times 37.25 divided by 25 equals 2.98 molar. Now, a fair question in that case is, well, what is the, actually I forgot one significant figure here, 2.980 molar. What did I just solve for? Well, I solved for the HCl concentration. And so I'm going to put brackets around that, and that's all there is to it. All right, well, I hope this is helpful. And like I said, I'm going to be posting a video that demonstrates kind of setting up a titration. And I think you got this. Chapter 5 in the books. All right, everybody, have a good day.